Okay, picture this. You're in space. No gravity. You're just floating around like a sock that escaped the dryer. Sounds fun, right? Like zero-G cartwheels all day? Well, your body hates it. Bones start to weaken, muscles shrink, your balance goes out the window, and get this, even your eyeballs can get messed up. Yeah, gravity? Turns out it's not just a vibe, it's kinda necessary for survival. So here's the million-dollar question. If we wanna explore deep space like Mars or beyond, how do we bring gravity with us? Can we fake it, build it, spin it up somehow? Let's break it down. No jargon, no boring lectures. Just real talk about fake gravity. Alright, so first off, gravity on Earth, it's just the planet pulling you down. Easy. But in space, there's no planet and nothing pulling. So to keep astronauts from turning into sad noodle people on long missions, we gotta get creative. One of the coolest ideas? Spinning the spaceship. Yeah. Like a giant wheel in space. When it spins, everything inside gets pushed outward. So if you're standing on the inside of the spinning ring, it feels like gravity. Like your feet are being pulled down. Your body doesn't really care that it's not real gravity. If it feels right, it works. Now here's the catch. You can't just spin a tiny space pod like a fidget spinner. That'll just make people dizzy and possibly very, very sick. The smaller the station, the faster it has to spin to create gravity, and that kind of speed turns the whole thing into a cosmic merry-go-round. Not ideal if you like keeping your lunch. To get that nice comfy Earth-like gravity feeling, the station has to be huge. Like Space Hotel huge. We're talking the size of a football stadium or bigger. NASA concepts like the Stanford Torus suggest a spinning ring with a radius of at least 100 to 200 meters. That size lets it spin slowly enough to feel like normal gravity without making everyone dizzy. Another idea? Constant acceleration. If a spaceship keeps accelerating, not just moving at a steady speed, but actually speeding up at a constant rate, it creates a force that pushes everything inside toward the back of the ship. That push would feel just like gravity. So instead of floating, you'd feel like you're standing on the floor, just like on Earth. To really match Earth's gravity, the ship would need to accelerate at about 9.8 meters per second squared. That's the same pull we feel down here on the ground. Problem is that takes a ton of fuel. Like unimaginable amounts. Unless we invent some magic future engine, think fusion or antimatter, we're not pulling that off just yet. Now you might be thinking, wait, don't astronauts use like magnetic boots or something? That's actually a sci-fi myth. NASA did experiment with magnetic boots early on, but they found they were awkward and not very practical. So instead, astronauts use straps, Velcro and foot restraints to stay in place. But here's the thing. While these tricks help them stay put, they don't solve the bigger problem. Astronauts still face muscle loss and bone weakening in zero-G because these methods don't mimic gravity. So it's a clever workaround, but not the real solution. What we really need is something that mimics Earth's pull, day in, day out. And while we're not there yet, scientists and engineers are working on rotating habitats, inflatable spin modules, and even some wild asteroid station concepts. Like mining an asteroid, hollowing it out and spinning it into a livable space donut. Yeah, sci-fi just got extra sci. So will we ever have real artificial gravity? I mean, yeah, eventually. If we're serious about long-term space travel, it's not optional. It's survival. We're not gonna float our way to Mars in lawn chairs. Now I wanna hear from you. If you were designing a spaceship, would you go with the spinning wheel, the constant thrust, or just float and vibe with zero-G? Drop your answer in the comments, hit that like button if your brain just got a little more massive from all this space talk, and subscribe for more deep dives like this. Thanks for listening, and remember, in space no one can hear your bones complain, but they definitely will.